All right, let's try out this problem called number of nodes in the subtree with same label. Let's have a read. So you're given a tree that is a connected undirected graph that has no cycles, consisting of n nodes numbered from 0 to n minus 1 and exactly n minus 1 edges. The root of the tree is a node, and each node of the tree has a label which is a lowercase character given in the string labels. That is, a node with the number I has a labels of I. Okay. The edges array is given in the form of like this. Fine. Return an array size where answer of I is the number of nodes in the subtree of the ith node which has the same label as I. Okay. A subtree of a tree is a tree consisting of nodes in T and of its descendant nodes. Seems quite basic problem to me. So we are given this tree and it says, hey, how many nodes are there in this subtree? How many nodes are there in this subtree, and so on, right? Is that what we have to tell? So n equals to 7 and the output is 2 1 1 1 1. Node 0 has label A. Oh, okay. Same nodes can have multiple nodes can have same label. Node 0 has label A and its subtree has node 2 with the label A as well, and thus the answer is 2. Okay, so the problem is this. The problem is whatever my label is in my subtree, how many other nodes are there with the same label? So there are one is me and the other is this guy. So which is why that it is 2, right? So now that is clear. Let's look at this another example. All are B. So for this node, there are total 4 nodes in its subtree, including itself with label B. For this, there will be 2. For this, there will be 1. For this, there will be 1. So the answer will be 4 and 2 and 1, 1, 4, 2, 1, 1. Yeah. Look at this example as well. So A. So this guy has 3, this guy has 2, this guy has 1 and 1, 1. So 4, 2, 1, 1, 1. Ah, okay, 3. Yeah, 3, 2, and 1, 1, 1. Makes sense. So the problem is clear. Now, how can it be solved? Let's look at maybe the last example is good one. Yeah, so let's look at the last example. I'll switch on to whiteboard. Okay, so what does this example say? We have a node 0, we have a node 1, a node 2, and a node 3. Okay, this is not the last example. But 0, 1, 2, 3, and maybe there is another child here, 4. And let's say this is A, this is A, this is A, this is B, this is B. Right? So I need to find out in my children, for every guy, I need to find out how many nodes. Yeah, it's a bit tricky one because, like, essentially, I need to know the information about my children before I can tell how many. Yes, I need to get the number of A's. Whatever I am, which is I am A, I need to find out the number of A's in all my subtree. So number of A's I will try to find out, but so that is fine. But when I come to 3 for this guy, I will want to find out the number of B's, right? So can the problem be that I want to find out everything? Like one of the things is I can find out the unique labels and then I can just count the well I can just keep counting the value for each label and return that from each node. So from each node I will return, basically I'll maintain a set of or rather count from, so I'll maintain a label to count map, right? And I will do this traversal in a sort of a post order fashion, right? And do a post order traversal. And because you do post order traversal, we'll always have the children first. Or like you can call it, I don't know, post DFS or whatever, but that's the general idea. So if you look at this example from 0, so let's maintain this label and count. So from 0, we go to 1 to 2. So 2 is label A. So label A's count is 1, right? And then when we are at 2, we know it does not have any children. So whatever its label is, that count is what the two will return, right? So that is fine. So that's count will. So we'll also do this 0, 1, 2, 3, 4, and 2 will return 1, right? Because that's the count of A. And then it goes to 1. 1 will say, hey, I am A. It will increment the count of A to 2. And for 1, it will return whatever A's count is. So 1 will change it to 2. And then we go to other children of 0. We go to 3. 3 is B. So B's count increments to 1. And B does not have any children. So this 3 did not have any children. So 3 will return 1. Then we go to 4. 4 will change B's count to 2. Now that's a problem. That's a problem. 4 will change B's count to 2. Hmm. So you can't maintain a global map because for 4, well, yes, total count is increased, but the total count is increased because of something else. So does that mean that every node will return a label map? Well, like that's the best thing to do, that every node can return a map, and then you can just add all of them up and return to the parent, and the parent will return that. So for example, this node will return all the label count, label A count, label B count, and so on. And that is needed because if you maintain just one global count, the problem is count between siblings, right? So let's say one is a global count, and the other is, yeah, I think just return this map from every node. So what that means is for A, 1, 3, and 4 will return three different maps. So 1 will return A as 2, and then 3 will return B as 1, and 4 will return B as 1. And what A will return is it will merge everything and it will return A2 and B1, something like that, right? And then that can be used by everything. Okay, so that makes sense to me. Let's build a logic based on this approach. So we come back to code. So what you're saying is, let's first build a tree. That's the basic stuff. So let's quickly build a tree. So we'll use a adjacency list based representation to build a tree. So we go list of uh, treasure adjacency list equals to new array list equals to 0 is less than n plus adjacency list dot add new empty array list. So now we have an empty list for each node, and now we're going to go through the edges. So for each edge in edges, we're going to do u equals to edge of 0 and u equals to edge of 1, and we're going to do adjacency list of u. We're going to add v, and in the adjacency list of v, we're going to add u. That's the basic tree representation. Now, what about these labels? So labels is given as a string. Let's convert that into a char array for ease of reference. So we do char array labels equals to labels. Oops. Okay, that's fine. Now, what's the job? Now we want to build a SAT, right? And that is something that will be returned by every node. So So ultimately, what do we want to return? We want to return count array. So let's build that. So int array count equals to new. What's the function name? Okay, that's fine. So it's a count matching. Just call it count equals to new int of size n. So that is fine. This is what we have to update, and we're gonna call a function call just doing a DFS or like a, just call it post order. So we'll do a post order traversal from starting from index 0. We need the adjacency list. We need the labels. We need the count array. I think that's it, right? So we're gonna saying that this is going to return a sat. So a sat from a label is a character. So a character to integer. We're going to return this sat and we'll do post order. And okay, so we have a integer index. We have a adjacency list. And what else do we have? We have a labels array and this count array. I think we also need a parent, right? So that we don't go back to the parent. So let's maybe take it 0 and we're gonna do int parent. Now, so we do is let's build this sat. So we go sat character integer. Oh, it's why are we calling it sites map? Um, I'm gonna call it label count. So it's a new hash map. So we're gonna first get the label counts from each and every children, right? So for each neighbor in the adjacency list of index, obviously we wanna ignore the parent. So if parent equals to neighbor, we ignore that guy. But other than that, we're gonna go uh, we're gonna get this returned by somebody, right? So equals to order. Its index would be neighbor. It's this list of lists is an adjacency list. So we pass this adjacency list. We pass this labels array, count array, and the parent would be index. Now we get the result from the child. Let's merge it into the parent. So now we go for each label in the child label count map. We're gonna do we're gonna increment it in our stuff. So we're gonna do label count dot add or rather put label and whatever the value we got from the child. So dot get label plus whatever is the value that we already have, right? So this should be fine, right? So we add the counts that we got from each and every children. And now what else? Now, well, there is one more thing to do, which is uh, count of whatever my um, index is. So count of index will be set to this label count dot get of whatever my label is, which is labels of index, right? And that's it. I think this makes sense. So we get the okay. What about well, if null nodes last node 0. I think you have to add one more case, right? So which is this label count dot put whatever my label is. So labels of index. Again, label count dot get or default. So you're gonna put at least one, right? Yourself, whatever my own label is, I'm gonna increment its count by one. So this is what like the leaf nodes would do. Leaf nodes will just add a one count to the to the label and pass it on, and the parent will add all of them up in add itself and then return the count that it has seen so far. All right, let's run code and see if it works or not. We get a compilation error. Let's fix that. So yeah, we have to return the count finally. All right, let's see. Missing is one statement line number 42. Okay, here we want to return this map. So we're going to do return label count. Okay, and again, and the three test cases pass. Let's submit and see if everything passes or not. And everything passes as well. All right.